Good morning to each one of you. I'm your host for the session, elevating. Uh, I'm the host for your for the session, uh, and of course the chair as well. So I lead Fidelity application architecture at Fidelity Investments. It's an enterprise architecture group focusing on core and common capabilities within the firm. And I'd like to take this opportunity to introduce both of my panelists for today. I have Ajay M, who is a VP Engineering and MD at Pure Storage, and I also have Vijay with me. So Ajay, would you like to just talk something brief
Sure.
about yourself before we just move ahead?
Yeah, sure. I mean, I'm delighted to be here to talk about very pertinent topics, sustainability and cloud. Uh, that's something that we do here at Pure Storage. We're building some of the most sustainable storage systems that aim to reduce the global carbon footprint in the next few years. That's what I do. Thank you. Thank you so much, Vivek.
Yeah, so hello everyone. This is Vijay from Walmart. I'm part of the platform group, which is an horizontal team focused on infrastructures. We have multiple public cloud adoptions, private data centers, edge stores, and data, all of app data, streaming data platforms, big data, AML platform. And the last one is developer productivity, how we can provide the best developer tools to ship the code faster and secure. The platform team focuses on all of Walmart business, international SAMs. We do support all of the business at Walmart.
So it's going to be a pleasure discussing this very relevant topic with both of you. Coming from an agile company like Fidelity, where we basically deploy emerging and cutting edge technology in financial services in areas like customer experience, analytics, operations, and research. We've always been a digital first company, but sustainability is an area that is gaining a lot of focus from us as we move forward. Right? As a wise man once said that when the winds of change blow, some people make a wall, others a windmill. Right? Either you evolve with change or you dissolve with it. Right? Business evolution today is all about digitizing your processes as well as workflows and reimagining them as computer applications. But the larger question is, where do you go ahead and deploy these applications that you have? And cloud has emerged as a platform of choice, a viable platform of choice to execute these digital applications. And there are two reasons for it. The first, of course, is that the cloud has reduced, significantly lowered the entry barrier for digitization by changing the cost structure away from a capital expenditure model to an operational expenditure model. And what that basically means is that instead of buying a flat, you probably buy a small space, or you probably rent a small space in a big house. It's completely inverted the cost structure. And second, of course, is it's moved away from a fixed scale compute model to a variable scale compute model. So, depending on the business relevance, you can either lower or increase or lower your compute as you go ahead. Right, so these are the two reasons which are basically leading to rapid digitization across the world. So one is, of course, the lowering of cost as well as availability of elastic compute. But the question is, can this digitization be a sustainable one? I think that's what we're going to be discussing today. And what do I mean by sustainable? I mean, sustainable is something that can go on forever. So you cannot keep cutting the Amazon forest forever. You can keep generating renewable energy almost theoretically forever. You cannot keep burning fossil fuels forever. We know the effects of carbon on our environment. So that's what I mean by sustainable. So I think Ajay is going to talk about some eye-popping numbers where we run all these digital transformation loads on cloud data centers, the amount of energy that they consume, and so on and so forth. So today this is a topic of discussion. So Ajay, let's start with you. The first question, right? So that is, sustainability is in the top of the mind of all enterprises, in fact, even governments and consumers nowadays. And as I just spoke about, with the digitization footprint increasing, this obviously increases your energy consumption for CPU, storage, as well as network that actually power most of these data centers. So I wanted to understand from you, what should be the enterprises be thinking in terms of planning for sustainability as they move, as the digital footprint increases, and as they themselves move their workloads onto the cloud?
Thanks so much, Vivek. So, yeah, I think the gentleman who spoke before me spoke about generative AI, and I can go home and I can see my daughter creating like thousands of images using Discord just because you can do it and it's available. So all of this and everything that's happening is giving like a multifold increase in data traffic. It's consuming CPUs. It's just inundating the digital channels that we have, right? But if you look at the impact it has had, roughly, I mean, this number varies, but roughly between 1 to 2% of the global carbon footprint is coming out of data centers. These could be data centers powering your clouds. It could be data centers that you have on-prem powering large enterprises. It's 1 to 2%. It's a staggering number. And if you look at major enterprises in the world who are committing to net neutral carbon emissions by end of the decade or end of next decade, they're primarily going about in a couple of ways. The easy way is to buy carbon credits, but that means I'm going to kind of pollute, but then somebody else is going to plant a tree, and let's see how that goes. The best way to do that is to reduce emissions overall, right? I think, and to do that, there are three things. One is, let's talk about digitization, right? So
Sure.
One is, we are at an extremely important point in time where we can make good decisions in procuring the right kind of technology. We do the right hardware and software architectures to actually support that. And thirdly, we write really responsible software, right? We are writing responsible software because we don't want to run up CPU costs in the cloud. It's very good because not just that your costs are under control, it's kind of reducing the carbon footprint. People are moving rapidly from the traditional data centers that they have, where they were using spinning disks as a medium for storing data, to flash storage, right? So it's my prediction that in the next 4 to 5 years, there won't be a single new hard drive that will be sold on this planet. Companies like ours are here to eliminate hard drives completely from this world, right? I think that's going to happen. And that's going to improve the sustainability of this planet overall. And that's happening. Yes, I mean, there are like cost pressures. I'll talk a little bit about what it takes and how real is this transformation a little later, but that's actually happening. And finally, how you architect your data center matters a lot, right? Your cooling and your choices that you make, right? So, yeah, so these are like some of the themes that we want to look at, right? And also then you spoke about SaaS, right? So when you talk about SaaS, you should also remember that there is a hardware that powers the SaaS. Currently, if you look at hardware life cycles, you invariably have a refresh in 3 years. So you basically throw out all your gear and bring in new gear. So it's a tremendous waste. So what if you did your hardware architecture in a manner where you can really reuse that gear and make it run for 6 years? You just double the life of that, right? So look at some of these levers that we have. So as the volume of data increases, somebody said that it kind of doubles every 2 years, and then that kind of increases, right? As the volume of data increases exponentially, your innovation should be such, and especially infrastructure providers like ours, should be such that your pace of innovation is more than that so that you can contain it. For example, flash storage consumes a tenth of power that the disk storage consumes, a tenth, an order of magnitude less. It consumes 1/20th the space, so basically you have lesser real estate, and then your cooling needs are that much lesser, right? So just an instance. So.
Cool. So, I mean, Ajeya just spoke about the macro picture, Let's get into the micro picture. I think one of the things which he spoke about, which was very interesting, was, using more energy efficient languages, right? I mean, with all this languages like Python and all, which are not very energy efficient, powering many of these AI systems, there are implications. But on a larger note, on a micro picture, what are the practices that firms should be following, things like FinOps practices and so on and so forth? Why don't you just spread some light on that and tell us, how can we do things at a micro level? Macro level, yes, Ajay did speak about it, but at a micro level, what all can be done as individual organizations?
Um, I'll actually, as the largest retailer in the world, Walmart has a very strong sustainability goals, like increasing our renewable energy. Um, for example, 1 gigaton of greenhouse gas emission by 2030. So we need to operate at all the dimensions. How do we run our data centers, stores, and we have a large fleet of transport. How do we actually run them and avoid the carbon footprint as much as possible? So the entire gamut of supply chain, including the suppliers, we are gearing towards that. That covers more on the macro side. Um, Specifically speaking to the cloud aspect of it, last year in the industry, 31% of the cloud is total spend was a waste. So either it is underutilized or most of them are like unused. So facade for the sustainability is what do I call it as a sustainability architecture. So three parts we can look at it. One, architecture patterns. Second is how do we optimize the performance of our application. And the third is the cost aspect of it. So as Vivek talked about the programming language, so most of us would have not seen it as detail is like a C language takes 1% of 1 unit of an energy compared to a Python and a Perl taking 80 units of energy for a specific algorithm, right? So when you put a lens of sustainability, the architecture becomes a little better. Most of the organizations already doing in the facade of like, I want to optimize my cloud cost, I want to optimize my performance, I need to optimize my architecture. Architecture could be the way we look at event-driven scheduling, serverless cloud computing. So all of these things is leading to a sustainability, so where we can reduce our carbon footprint. When we ship a bad code, we are not introducing defect. We should also understand that we are impacting the environment somewhere, right? So these are the micro aspect, and a lens of sustainability as one more dimension to an architecture. And awareness would definitely help, where people, while they read code, they're also adding a cost to the global environment.
Yeah. Actually, yeah, to actually make this whole digital transformation successful, it needs to be sustainable. In case, if we can't make it sustainable, it probably won't last over a very long period of time, and we won't be able to move the kind of digital transformation that we want to do across the world right now. So one of the things I was reading the other day was the amount of terawatts of electricity that's actually consumed. I think India consumes around 1,600 terawatts. This is from the energy agency. I think we consume around 1,600 terawatts of electricity per hour. And the data centers, including this blockchain mining, centers which are there, I think they consume around 450 terawatts of electricity per hour. I mean, that's huge, right? I just wanted to understand from you, this whole talk about green data centers. There are some players who started getting into it right now. But what is your definition of a green data center? And what are all the different components of green in that green data center?
Yeah, great question. But before that, I just want to say that sure. I didn't know that Python and Perl took 18 times more power than C. I knew it was like that, but thanks for that. I didn't know. So coming back to this, right?
Yeah.
The various components in a data center, I think networking, compute, and storage, right? Yeah. From everything that I know, storage is one of the biggest consumers of the power as part of the data center, right? And when we are talking about green data center, we are really looking at, like, since we are into storage, I'll talk a little more about that, about replacing disks with flash. So what does that mean, right? That means, let's say, a direct flash module that's as big as my iPhone, right? and actually hold today about 48 terabytes of data, right? And we are innovating here, right? We are innovating on this, right? The basic unit of storage on which you actually place data, it's called NAND, right? It's called a NAND chip on which you write data. There are different levels of NAND chips, right? So first you have like SLC, which is a single cell device, where you can actually store 1 bit of data in a cell. Then came multi-cell, where you can store 2. And then came TLC, where you can store 3. So what does it mean, right? It's like putting more and more electrons in a single cell, which is like making it really unstable, right? So today, what we do is called QLC, quad level cell, which means like 4 bits of data in a single cell. So which means the same 48 terabytes of direct flash module will have 150 terabytes in the next 1 year, right? But the amount of power it consumes will be the same.
Wow.
The amount of cooling you need is the same. The form factor of your device remains the same, but then it's consuming way less power, even if you actually quadruple the amount of storage that you actually put on that. So that would be a green data center, where you are having, then you can look at your switching and routing networks. And what is the most efficient way to do it? Like how many top-of-rack switches do you need? What is the level of redundancy you actually need, right? Then you can look at your compute cores, right? And do a lot of hardware innovation, right? So does your fan have to, rotate at the same RPM even when so much of cooling is not needed, or can you kind of reduce it, right? So there are many different ways by which you can actually crush down the costs of running, power cost of running a data center to a third of what it is today if you make really intelligent choices. So that is happening. The second aspect is economics of this, right? Why are disks cheaper, right? So a couple of companies that are really keeping disks running in the market today are basically because you have these large cloud providers who have good tiering mechanisms, and they use that for, let's say, long-term storage, right? But the economics of flash is actually coming down. So there are a couple of different ways of doing it, right? So people have written a lot of software stack on disks, and they are unwilling to move to flash. So they have invented this new paradigm called SSDs. All of us are aware of SSDs, but what is an SSD? SSD is a solid-state drive, which all it means is you have a conversion layer on top of flash that makes your flash appear as disk to the software that is operating on top of it. It's a translation layer. But now there are newer companies, right, that are coming up and they're saying, we don't want that conversion layer. We'll directly write new software stacks that work directly with flash and double the efficiency right away, right? So that is happening, right? And that actually that reduces cost, right? The cost of NAND itself is falling globally, right? So recently we launched a product called FlashBlade, one of the products that I manage, where at scale, at a 4 petabyte scale, per gigabyte of disk versus flash is exactly the same cost.
Okay.
And the world is moving towards that. So if you take economics out of the equation and say, hey, we are at the same cost, forget about long term. Long term you will be because of power savings and space, but even pure raw gigabit per dollar per gigabit, you're at the same, then I think I see no reason for this to exist. And that will basically trigger the green revolution. And I'm pretty confident that even after a decade, our power consumption will be around the same numbers because people would have upgraded to more efficient ways of doing things.
Yeah. I think there are two other points as well, right? I mean, the whole idea about making these data centers consume energy from renewables, right? I mean, wind energy, solar, and many other things. And one major cost for almost all the data centers is air conditioning costs. That is, because all these, there's a lot of power which is dissipated while compute or storage is being done, and you need to dissipate that power out by doing air conditioning. And some companies are nowadays taking their data centers under sea in cold regions just to avoid the costs as far as air conditioning costs are concerned. So coming to another question, Vijay, and this is around, people are moving to the cloud. They are there. But one of the big issues is how do you de-risk your business, right? You're running a business and you go into a single cloud provider. What happens if certain region goes down or a certain area goes down and so on and so forth? Or the company, there's a problem with the organization and so on and so forth. So how do you de-risk your business, right? So how do organizations think about this whole idea about multi-cloud, hybrid cloud? I mean, all these buzzwords which are floating around, but the whole idea is about de-risking your business, right? So that you're not reliant on just one cloud provider. Just as all big airlines, their orders always comprise of Airbus as well as Boeing. It's just to make sure that both these companies are firstly competing with each other as well as they're always there. So, wanted your take on this whole idea about multi-cloud, hybrid, and de-risking part of it.
Yeah, so I've been in the journey of multi-cloud, hybrid cloud for the last 3-4 years. Distributed cloud strategy, definitely a good viable option for large enterprises. If it is a public cloud, like 2 or more public cloud, we call it as a multi-cloud, and you add private data center, hybrid option. Most of the time, we think having a multiple vendors, we can actually negotiate the cost. Vendor locking is avoided, but that's one part of it that I'm sure all of us are aware of. What really matters is we have seen the cloud capabilities when we adopt are not matured most of the time. They also mature over a period of time. So most of the business initiatives kind of delayed because even the cloud technology is also evolving. So having a multi-cloud can de-risk that. That's one of the important aspects. And especially I can talk from the Walmart scale. When we go for a seasonal bust, single provider cannot give the kind of scale that we look at. So we look at both multiple clouds plus our own data centers to scale. HADR, application resiliency, where one data center completely goes down, switch to traffic. In 2 minutes, we will have everything served by another data centers or another vendors. For a period of last 3-4 years, our cloud strategy, especially at a scale of Walmart, we have really built a very good abstractions across all these strategies to leverage. When I go to the hybrid data center, like private data centers, it's a cost king. Over a period of 6 to 8 years, the capex and opex, we save approximately 60 to 70% of the cost. Nobody can beat that anytime. And especially legacy application, which doesn't scale like the end customer applications, we don't have to take it to the cloud, public cloud. And the most of the home office, which is more internal, secured finance applications, can all stay in the private very comfortably. And even end customer application, if I deploy it in a private, and when there is a seasonal bust is required, I switch it over to the public where I scale much more comfortably. But at the same time, going back to the sustainability where I don't consume the cloud, public cloud, but I bring back to the private. So multi-cloud and a hybrid cloud are very, very interesting for the organization who already have invested in a hybrid, like private data center and hybrid strategies. And organization who don't have a data centers, multi-cloud definitely help in most of this aspect.
Thank you. One question on the sustainability front, right? Just as they say that cloud is a mindset, right? In the sense like when you go and take an application and deploy it on the cloud, just the way it's architected to be able to take advantage of the ecosystem that's available, it has to be different from the way it used to be done before, right? What about the sustainability part of it, right? I mean, what are the sustainable practices or the sustainability mindset that organizations should be thinking of inculcating in probably all the associates within the organization? You can probably talk about it from a macro level as well as a micro level, whichever you want to talk to, that the ecosystems benefit out of the sustainability mindset.
No, absolutely. So a couple of things, right? I think one of the advantages is the way you distribute your data across your data centers is important. So there is this concept of replication. So let's say I'm opening my store today morning and I need to have all the data I need to actually work through it. And as the day progresses, you're making transactions, right? But then there is another geography that's coming up, and these transactions are pertinent to actually replicate the data, right?
Okay.
So there is a way to do that. There's a way in which you can make sure that people are in sync by not transporting a whole bunch of data, but just a part of it that's required for whom. So there is a way to kind of fan it out to multiple locations so that everybody stays in sync, and then fan them in into a central data center at a certain point in time, right? When your networking loads are low, so that you are able to conserve power.
Yep.
That's one. Secondly, it's about understanding a good level of tiering in terms of what is your most frequently accessed data versus what is it that you don't. Like a lot of analytics are on that. So basically your nearshore data centers, right? The medium of storage where you actually place that data, right? Usage of how much of RAM do you use versus how much of flash storage that you use, because the more amount of DRAM you use, you consume a lot more power. So how do you want to architect that piece? That actually makes a big difference. And then there are a lot of practices that are very well known, including, let's say, swim lanes, multi-tenancy, what data is shared and what is not shared, right? So how do you actually set up queries for that? How do you intelligently use cache so that you don't have to go hit your database every time, but you have data readily available, so you reduce that many amount of traverses to your backend, right? So technically there are so many things that can be done, but first you have to decide what is important for you and how you actually go about doing that.
Vijay, you want to add something onto that one?
I think time.
I think we're up.
Yeah.
You have a minute. You should.
Yeah. So this is actually again going back to the architectures and how we want to leverage more from sustainability and the scalable part. So one aspect that I always look at is that when we look at the architectures again at the micro levels, as to summarize, most of the time we don't look at the way we actually get into the weeds of how do we consume the cloud. Right? It is we think that it's available. It's available for everyone to go ahead and then consume. And at the same time, when we start consuming, the organization gets into a debt of coming out of that cloud cost. So as a key takeaway is one, always look at cloud as a resource where when you're consuming, it is also that we are kind of providing some kind of an impact to the global data centers and kind of carbon footprint, and make sure that the learnings of the sustainability goes into especially the architecture teams, where they can actually bring all of those learnings and translate into how development teams can actually take it forward.
All right. Thank you, Ajeya and Vijay. It was a pleasure interacting. The things that come out of at least what we just spoke about was you can have your cake and eat it too, in the sense like digital transformation can be successfully done in a sustainable manner, and we need to take a bottom-up approach, right? Right from how you code to how you architect to how you pattern, as well as how you go and deploy your workloads onto the cloud. Thank you very much. It was a pleasure bringing this session to all of you. I hope you enjoyed it as much as we enjoyed presenting to all of you. Thank you.
Thank you. Thank you so much, Vivek.
For more content on tech and leadership, subscribe to NASScom YouTube channel and press the bell icon to never miss an update.